The is operator is a powerful thing. Checking for a subtype of an object is used in many areas, for example in state management with BLoC or Redux. Think about all of those events and states. How many times have you forgotten to check for a particular type in an if or a switch statement? There is simply no way outside of juggling all of those different classes in your head to make sure that every type is being checked for. Not anymore. There actually is a way to make you never forget about checking for a certain type. While many other languages have this feature built into them, I mean, come on Dart, for us, Dart developers, there is a package for it, sealed unions. Hello, welcome to ResoCoder, where you are getting prepared for real app development by building better, faster, more stable apps. So subscribe and hit the bell if you want to grow your coding skills. The sealed unions package comes from joining the names of two similar programming concepts, and those are sealed classes, which are for example in Kotlin, and tagged unions. Regardless of how you decide to call it, this package provides a way to make sure your code is robust. Forgetfulness goes out of the window when the app simply does not compile when you forget to check for a type, or for a subtype to be more precise. First and foremost, let's add sealed unions to the project, so let's open up pubspec.yaml, and I am going to demonstrate it in a plain Dart console app. But of course, this also works with Flutter and with any kind of third-party package which you want to use for state management or whatever. Sealed unions work with all code you can possibly think of. And be sure to check out the written tutorial from the link in the description, where you can also find all of the code written in this video, links to all of the libraries, and overall go through this lesson at your own pace. So after we have sealed unions in here, let's first take a look at how the code looks like without the use of sealed unions. I am going to demonstrate this sealed unions package on weather state. Imagine that we are building a weather app with BLoC, but it doesn't really matter. What really matters is that we have the base class weather state, and then we have three other classes: weather initial, weather loading, and weather loaded, which contains a temperature, and all of them are subclasses of the base weather state. That's what's important. The circumstances of we are using states and whatever are not important at all. This is sort of mimicking the states which you would use with the BLoC package for state management, and if you want to learn about BLoC in depth, definitely check out the tutorial from the card in the corner. Basically, weather initial would prompt the user to search for a city, weather loading would display a loading indicator, and weather loaded would display the temperature on the screen. And with the code looking like this, the way we would check for a particular subtype of weather state would look like this. So we have a widget builder, fake widget builder, which just returns strings, and it accepts weather state objects. So to check for the particular subtype of weather state, we would do the following, which is pretty common to see in Dart code. So if state is weather initial, we want to return some initial widget. However, if state, so else if state is weather loading, we want to return circular progress indicator. So in the case of this demonstration app, we're going to return it as a string. And then finally, so else, or should we rather do else if? Because what if we add another state? Well, you know, we'll just leave it to be sorted out by sealed unions, because here you can see that we have some problems, because if we add another state and if we leave this as just an else clause without checking for a subtype, we're gonna be in deep trouble. But if we check for else if, we're going to be left with a message that we are not returning string always from this widget builder method. So either way, we are going to be in trouble. But regardless of the trouble we are getting ourselves into, we're going to just let it be sorted out by sealed unions in just a bit. But If we are not using sealed unions, we would just check for if state is whether loaded, and if it is, we would return another string containing the temperature is, and interpolate the state.temperature, and that would be it. We now have a warning that we are not returning. Function is a return type of string but doesn't end with a return statement. But if we could definitely return null, but that's not a good practice. I hope that you can see that. So we are left with some bad looking code. So there is no possible way to enforce that we check for every possible state. And also, if we were to add a new, for example, whether error state containing an error message, because the data could not be gotten from an API, for example, if we did not remember to add the whether error check in here, well, we would not handle the whether error state. So that's definitely not good at all. But we can use sealed unions to solve all of our if and switch statement problems. Because of course I'm demonstrating this on an if statement, but the same problems would be present inside a switch statement as well. So let's start off by modifying the whether state classes. How will they look like once we start using sealed unions? Well, believe it or not, these whether initial, loading, and loaded subclasses of whether state will no longer really be subclasses. Let's see. We are going to actually remove the extends whether state, and also we are going to make them package private because we will not even want to be able to see them from outside this whether state file. So that's interesting. We still want to be able to be represented by just the whether state alone, but it doesn't seem like we are getting there, right? Well, hold on. We are going to also make this class whether state not abstract, and we're gonna make it extend union 3 implementation. So let's import sealed unions.dart over here. And of course, sadly, as with anything which tries to replace Dart's lacking functionality, because really, come on Dart, let's implement some unions or something like that, because it's completely crazy. I know that they are working on that. If you check out the GitHub repository for the Dart language, there is some buzz around adding sealed classes and stuff, but yeah, you are always going to get some boilerplate if you are trying to replace some lacking functionality of a language. So what this union 3 implementation will have as type parameters are whether initial, then whether loading, and also whether loaded. So let's put it over there. So all of the types which the whether state or any other base class can represent have to be specified as type parameters for the union 3 superclass. And of course you can go union 2, union 4, or maximally you can go up to union 9. So you can unionize 9 types. And I think that's plenty enough. But we are using union of 3 types. Then comes the boilerplate, so brace yourselves. We are going to create static final factory, which will be equal to a constant triplet. And if you are using union 4, you would use quartet and quintet for 5 and nonnet for 9 types and so on. But we are using union of 3 types, so triplet. And this triplet again has to take in some type parameters. So again, whether initial, whether loading, and whether loaded. You should notice that this factory is with an underscore, so it's private, and it will be used for instantiating the individual, so to say, subclasses, because they are not really subclasses. They are just the types which can be unionized into whether state. So this factory will be used only within the whether state class. You'll see in just a bit. Then in order to actually create instances of whether state, we of course need to have a constructor, but it will be private again, because we do not want to use it from the outside. From the outside, we are going to use our own custom factories of weather state. So this will just take in a union 3, not the implementation, but I think that implementation would be also fine to type here. But we are going to use the union 3 abstract class. If we take a look at that, union 3 implementation implements union 3, as you can see. This will again have these 3 type parameters. So really, there's a lot of boilerplate, I feel you, but you will have to decide yourself whether or not it's actually worth it to add this kind of boilerplate, or if you would rather just remember to do if checks yourself. It really depends on the situation. So this parameter will be called union, and let's just pass it into the super constructor. So super and pass in union. All right. And finally, we are now going to create public factories which will hide this triplet and this private constructor complexity from the outside classes. So the first factory will be weather state, and it will be called initial. And this will, of course, return the initial state, so weather initial. But the way we can instantiate that so that it can be unionized into weather state is by calling weather state, the private constructor, of course, so dot underscore to invoke it, and we want to pass in a union. And how are we in the world going to get union passed into the constructor? Well, we are going to use this private factory, of course, of the triplet. So the triplet can create the first. So first is weather initial. If we take a look at the implementation of the first method on the triplet, we can see that it does something like this. It instantiates a new union 3 first, then for the second, it's gonna instantiate union 3 second, and so on. And of course, union 3 first is a subclass of union 3. So we are practically creating subclasses with our states here, but they are sort of indirect subclasses, if that makes sense. So we have initial factory, and we also want to have similarly loading factory. So this will output second, which is weather loading. And finally, we want to have weather loaded, so loaded factory. And this will actually accept some data, so int temperature. And this will instantiate the third type, which is weather loaded, and pass in the temperature, of course. So now, I know this is a lot of boilerplate, but we have all of the necessary stuff implemented in order to use unions. So why did we even create a union in the first place? Well, let's see, by going to main.dart, and over here, we can no longer check for whether or not the state is weather initial, because weather initial does not even exist because we have added the underscore before that, if you remember. So instead of this, we are going to return state, which is now a union 3 subclass, dot join, and here we can map first, map second, and map third. So let's do just that. We're going to map first to a function. It needs to be a function which returns some type. In our case, it will be the string, and it accepts the first class, which in our case is weather initial. So let's say initial, and it will be a simple function just returning the string some initial widget. So let's just copy it from down there. And we similarly want to have map second, which will return circular progress indicator string. And let's just call this parameter loading And the absolute third method will be loaded, and it will return the temperature string. So let's do just that. And of course we want to get it from the loaded state. And now we can remove this unused broken code. And it's immediately obvious that we cannot forget to check for a particular subtype, so to say, of weather state, because like if we, for example, forget to check for loaded, we do not have enough arguments for the join method, so the code will not even compile. So we have to check for everything. And also, if we were to change this to be union 4 and blah, 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 we would add some weather error state and so on, we would again get an error here because now there are 4 required arguments when the union is of 4 types. So we cannot possibly forget to check for a type. So let's just finally check if this code actually works. We're going to print widget builder and pass in weather state initial, right? So let's run this code. Of course, I do not want to run tests. I want to run Flutter. What? I don't want to run Flutter, but anyway, even though we are not on Flutter, when I run the Flutter configuration, I still get out the some initial widget string. If we now change it to loaded and pass in temperature 42, and now run this code, we're going to get the temperature is 42. So this state.join really works like an if statement, but you cannot possibly forget to check for a case. To go through this tutorial at your own pace once again and to get all the code, check out the written tutorial available from the link in the video description on resocoder.com. And if you do not want to miss more tutorials like this, definitely subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter and Dart coding skills, because here on ResoCoder I am determined to provide you with the best app development tutorials and resources out there. If this video helped you with understanding sealed unions and how to actually utilize their power in your apps, give this video a like and also share it with other developers who will surely benefit from not forgetting to check for a subtype too. Leave a comment if you have any suggestions or questions or anything else to say. Follow me on Instagram, I go under the name ResoCoder everywhere, and see you in the next video.